Good day, students. My name is Mr. Benibo Briggs, your maths teacher at Sleek Angels International School. I trust God you're doing well at home. This will be our next revision class following the one we had previously. In today's class, our topic will be areas of plane shapes. If you remember vividly, we had treated this topic in class before. And since you're at home, we'll be doing a revision on this topic to remind you of some of the things you may have forgotten because your exams are coming up. So, lesson objectives. By the end of this lesson, the students should be able to recall, firstly, the formula for finding the area of a trapezium. Secondly, you should be able to recall the formula for finding the area of a circle. And thirdly, the formula for finding the area of a sector. Now we'll be treating these three shapes and finding their formulas and how they apply towards problem solving. Okay? So I'll just quickly jump into the first example. As you can see here, it says, what is the value of x in the trapezium below? What is the value of x in the trapezium below? Now someone may ask me, sir, we have a trapezium here. We also have another trapezium here. I'll make a mark with my red pen. Someone may say, we have two trapeziums in this figure. We have the first trapezium bounded by these four lines, and we have the second trapezium bounded by these four lines. So, which trapezium are we referring to? Now, the trapezium we are referring to is the trapezium bounded by these four lines. According to the question, it says, what is the value of x in the trapezium below? And the area of the trapezium is given as 35 centimeters squared. The area of the trapezium I have quickly marked out is given as 35 centimeters squared. Now we'll move ahead. What is the area of a trapezium? Now, our formula for finding the area of a trapezium is half multiplied by the sum of the parallel sides times the height. Our formula for finding the area of a trapezium is 1/2 multiplied by the sum of the parallel sides times the height. What are we talking about? If you look at this trapezium right here, it has these two sides parallel to each other. That is why we have these two arrows here, showing that these two lines are parallel to each other. Okay? Now you may ask me, looking at this trapezium shaded here, how can we find the height of the trapezium? If you carefully observe, since these two lines showing 6 centimeters and 8 centimeters are parallel to each other, it means that the height we have here from this point to this point, which is x centimeters, is the same thing as what we have here. What do I mean? I'm saying the distance from this point to this point is the same as the distance from this point to this point. And the distance from this point to this point depicts the height of this particular trapezium. The formula for finding the area of a trapezium is given as half multiplied by the sum of the parallel sides of the trapezium multiplied by the height of the trapezium. Now, looking at this trapezium here, we have two parallel sides side of length 6 centimeter and the other side of length 8 centimeter. The arrows here show us that these two lines are parallel to each other. So we have the length of the parallel sides. Now someone may ask me, what is the height of this trapezium? That's what we are looking for, the value of x. If you look at this trapezium, since these two lines are parallel to each other, it means that this distance from here to here, which is the height here, is the same thing as the height of this trapezium. So we are saying if this distance from here to here is x centimeters, the distance from here to here is also x centimeters. And that tells us the height of the trapezium. So, given here the area of the trapezium is 35 centimeters squared. If we impute every data we have here into the formula, we'll have something like this. Area of the trapezium, which is 35 centimeters squared, is equal to 1 over 2 multiplied by, as I said earlier, the sum of the parallel sides of the trapezium. The parallel sides we have here are 6 centimeters and 8 centimeters. So we'll sum them, we'll have 6 plus 8 multiplied by the height of the trapezium, which I earlier said is x centimeters. So we have something like this. 35 is equal to 1 over 2 multiplied by 14 multiplied by x. If 2 cancels instead there once, cancels 14, we have 7. So we have 35 is equal to 7x. Now, for us to be able to find the value of x, we have to divide both sides of this linear equation by the coefficient of x here, which is 7. So if we divide both sides by 7, we have 35 divided by 7 is equal to 7x divided by 7. 7 cancels itself once, cancels itself here once, and cancels 35 5 times. So it means that the value of x is equal to 5 centimeters. Therefore, the height of this trapezium is 5 centimeters. We'll move. Example 2 says, find the area of a circular ring whose outside and inside diameters are 8 centimeter and 6 centimeter respectively. Take pi as equal to 22 over 7. As you come over here, you see a diagram depicting the circular ring we are talking about. The circular ring is a plane figure that has 2 circles, a bigger one and a smaller one. It's just like what we have here. We have a smaller circle inside with an opening, then a bigger circle outside. So this is the area we are referring to. This is the area of the circular ring. The shaded portion is the area of the circular ring. Now, for us to be able to find the area of a circular ring, we must first know the area of a circle. So, formula for area of a circle, which we should already know, is pi r squared. So, since we have 2 circles here, a bigger one and a smaller one, then the area of a circular ring, which I previously thought is the area of the bigger circle minus the area of the smaller circle, where we use big letter R to depict the radius of the bigger circle, while small letter R to depict the radius of the smaller circle. So if you look at these two, you find out that something is common. Pi is common. So if we factorize here, we get pi into big R squared minus small r squared. This formula is the formula we use in finding the area of a circular ring. So let's begin. According to our question, let's find out the area of the bigger circle. So area of a circle, which is pi br squared is equal to 22/7 multiplied by our radius. Now, if you observe, in the question we're given diameters as 8 centimeters and 6 centimeters. And we know that to find the radius of a circle from the diameter is the diameter divided by 2. So the radius, which I've already written here, of the bigger circle is the diameter, which is 8 centimeters divided by 2. That's what gives us the radius of 4 centimeters. Also, for the smaller circle, small radius is diameter divided by 2, which is given to us as 6 centimeters divided by 2, which gives us 3 centimeters. So we have here 4 squared, which gives us 22/7 times 16. I'm just going to leave this here. Area of smaller circle will be 22/7 multiplied by 3 squared. Coming over here, that will be equal to 22/7 multiplied by 9, because 3 squared is 9. But if you remember, we already have a formula here covering all of these. So if we impute all this data into that formula, we have area of circular ring equal to, according to what we have there, pi 22/7 into big R squared, which is 4 squared, minus small r squared, which is 3 squared. So we have 22/7 multiplied by 16 minus 9. And 16 minus 9 gives us 7. So we have 22/7 multiplied by 7, which cancels itself out to give us our area of circular ring equal to 22 centimeter square. Example 3 says, find the area of the shaded portion in the figure below. Now, looking at the figure below, this figure shows us a sector of a circle. Now, if you look at the shaded portion here, for us to be able to get the area of the shaded portion, which represents the segment of a circle, we have to take away the triangle from, we have to take away this triangle from the sector for us to be able to get the segment here. So, area of segment will equal to area of sector minus area of triangle. Now, looking at this, we have one radii given to us as 7 centimeter and the other radii also given to us as 7 centimeter. So, for us to find the area of a sector, the formula for finding the area of a sector is given to us as area of a sector is equal to theta over 360 degrees times pi r squared. Theta over 360 degrees times pi r squared. Now, looking at this figure we have here, sector, our theta represents the angle at the center of this sector. And if you look at this, it shows that we have a 90-degree angle. So I will impute that here as 90 degrees. divided by 360 degrees times our pi, which is 22/7, times our radius, which is 7 centimeters. So we have 7 multiplied by 7. So this 7 can comfortably cancel this 7. 0 can comfortably cancel 0. 9 can cancel itself 1 time and cancel 36 4 times. 2 can cancel 4 2 times and can divide 22 11 times. So we're left with 11 multiplied by 7, which gives us 77/2 centimeter square as the area of this sector. Since we have been able to find the area of this sector, all we need to do is to remove the area of this triangle, then we'll be able to get the area of the segment. So, area of triangle. Now, if you remember, I had previously in class given you so many formulae, different formulae for finding the area of a triangle. Looking at this particular triangle, all we're left with are 2 sides and an included angle. We have the length of 2 sides and an included angle. So the formula we're going to use is, area of a triangle is half AB sine theta, where theta is the included angle and AB represents the length of the sides given to us. So this will be 1/2 multiplied by A, which is 7 centimeters, divided by B, which is also 7 centimeters, multiplied by sine 90 degrees. Now, I had previously taught you how to find the sines, cosines, and tangents of angles between 0 to 90 degrees. So, from our trigonometrical tables, sine 90 degrees is equal to 1. So we are going to have something like this. 1/2 times 7 times 7 gives us 49, multiplied by sine 90, which is 1. So the area of our triangle is 49/2 centimeter squared. So since we have been able to find the values of the area of the sector and the area of the triangle, therefore the area of our shaded portion, which is the area of the segment, equal to the area of the sector minus the area of the triangle. The area of the sector is 77/2 cm squared minus the area of a triangle, which is 49/2 cm squared. Okay, since they both have the same denominator, we'll have this to be 77 minus 49 all divided by 2, which is the same thing as 28/2, which gives me finally 14 centimeter squared. So the area of the shaded portion, which is our segment, is 14 centimeter squared. Okay, I hope you've been able to enjoy this class, and we'll move on to your assignments now. The first one: the walls of a toilet 2.5 centimeter long, 2.05 meter wide, and 3 meter high are to be covered with tiles 15 centimeter by 50 centimeters. I'll read again. The walls of a toilet 2.5 meter long, 2.05 meter wide, and 3 meter high are to be covered with tiles 15 centimeter by 15 centimeter. A saving of 108 tiles is made on doors and windows. How many tiles will be needed altogether? Note that some tiles will have to be cut. Now, the reason why I chose this example is because it's a real life example. So if you have any problems, you can easily go to your toilet and look at how it is built, and you'll be able to have an understanding of what to do here. Secondly, it says the windscreen wiper of a car sweeps through an angle of 150 degrees. The blade of the wiper is 21 cm long, and the radius of the unswept sector is 6 centimeters. What area of the windscreen is swept clean? I read again. The windscreen wiper of a car sweeps through an angle of 150 degrees. The blade of the wiper is 21 cm long, and the radius of the unswept sector is 6 centimeters. What area of the windscreen is swept clean? If you move over here, you have a diagram for question number 2. Okay? So you have length 6 centimeters from here to here, and length 21 centimeters from here to here, and the included angle, which is 150 degrees. If you have any problems, you can easily go out, you see a car around, and you look at the wiper, and to help you easily solve the problem. Once again, my email address is askbenny247@gmail.com, or if you can't reach me there, you can reach me via WhatsApp at 0806 361 0526. Thank you once again for listening to me. God bless you. Have a nice day.